So welcome to this hands-on video. I've got a couple of these Raspberry Pis that arrived this morning from Pimoroni. They're the 4GB version and they have a new addition, a USB-C for the power and two micro HDMI, so you're going to need a new adapter to use a screen with this. We've got two USB-C ports, two USB 3 ports that are higher bandwidth and two regular USB 2. Our Ethernet port is also gigabit. Now, I did some testing on this earlier, and one of the things that I found to be quite surprising was the bandwidth that I was getting through the device using iPerf was around 1000 gigabytes. Really quite fast, going in both directions from a Raspberry Pi to a NUC and vice versa. So you can check out some of the details on this thread, but one of the things I did was to deploy the OpenFAS project to it. And I thought what I'd do is I'm just going to show you now exactly what I did and recreate it for you. So first of all, what we'll do is log into one of the Raspberry Pis. So the Pi is a default username. And as soon as you plug it in, you're going to get this name of raspberrypi.local. And the password is raspberry. So we can see immediately we've got a security risk. So we need to go and change our password. I'd encourage you to use a strong password. And now if we log in again, we'll see that we no longer get that warning. But I don't like typing passwords, so one of the things I'm going to do is copy my local SSH key up into the Raspberry Pi using this command. And now when we use SSH, we'll see that we get straight into it. Now if you don't have an SSH key, you can run the SSH keygen program and it will generate one for you. Now I also don't like that name, Raspberry Pi. I'd rather it was something else. So let's go into the network options, host name, and because I've got two of these, I'm going to call them k3s 1 and 2. Then there's another thing I like to do in the advanced options is we can change the memory split. Now I have the light version of Raspbian here, so we don't actually need memory for graphics. The lowest I think we can use is 16 megabytes. And that's pretty much it. So for now, we've got this free memory where a proportion of it has been used, but if we do a reboot, we'll be able to come back in. This time the name will have changed to k3s2.local. The key that we put on there earlier will still work. And I have one that I built earlier below, k3s1.local. And this one, it has my key on already. You'll see it has a bit more of the RAM available. So the key has changed. I'm going to get rid of the old entry and log in again. Okay. Now we've got a new host name and a bit more of that RAM available. So what I'd like to do is install k3s or Kubernetes using my tutorial Will It cluster. K3s is a lightweight version of Kubernetes developed by Darren Shepherd at Rancher Labs. And basically once you've bought your components and flashed your image, it's just a case of running through the steps and bootstrapping a server. Now, let's see if we actually have anything on here already. So we do actually have a server on here already, but we probably don't have anything on here at all at the moment, right? Because it's just a brand new Pi that I flashed. So what you can do on your first Pi is get the token, and if you haven't already got a Pi running this, it's really a case of a single command, and that's all I ran on here earlier. Now I've got this token, I can go over to my other computer and put it in environmental variable. Let's make sure there's no spaces in it, and then I need to put the k3s URL. It's probably best if we just get the physical IP address, and it's HTTPS, the IP, and then 6443, so an alternative port for HTTPS. The next step is just to run a single command, and it's the same one that we ran above, but actually in this context, because we've got some environmental variables, it's going to join that into the cluster instead. So if we get the nodes and we actually watch them, once the installation's complete in the top screen and the networking starts its thing, we should see it appear as another node. In the meantime, we can see that a k3s agent was installed as a systemd service. First of all, when Darren put this together, you used to have to just install the binary and work out everything on your own. And one of the earliest bits of feedback I gave was that we should really have Systemctl. And this is just great for the logs and figuring out what's going on. If you need to edit a setting, you can find that through the service file. Here's the service file. And you'll see the service file has some settings in an environmental file. So if you do need to go back in later, if the IP's changed or one thing or another, you change the token, you can just get back to where you were. So Systemctl status on the agent, and then we can do the same thing over here, but we're not using that suffix of agent here, and we'll see that there's a whole bunch of output debug. Right, so let's see if we actually have any pods or anything like that. All of the namespaces. And we basically get all of these bits on there whenever we install k3s. They're just the basics that it comes with. Now we shouldn't be able to actually run kubectl on this machine because it's not the server. Right, so we need to now use the bottom one to control everything. So we've effectively completely set up this node. All we did was create 2 environmental variables and then run a script. And you could imagine how you could automate this entire setup with something like Ansible in a very, very short period of time. Okay, so let's see our nodes again. And we're going to go output wide. And we see both of them are running Buster, which is the latest version of Raspbian. We've got the kernel version matching the internal IP. We can even go and describe the node and just get a bit more information, like whether there's problems with the limits or if it needs a bit more resources. Great. So what else did we do in the blog? Well, we went off to deploy a microservice, which was something that I brought over from OpenFAS, but we can go one step further than this, and we could just actually deploy OpenFAS instead. What we need to do is go to the OpenFAS faas-cli repo, and I cloned that earlier. Within here we've got a namespaces file which we can apply first, and then we can simply create all of the YAML files that we'd use to configure OpenFAS on ARM, like so. And these will now just take a few moments to come up. One thing that I like to do sometimes is use a swatch command, and you'll see some of these containers will come up and fail, and then they'll restart and try again, and then they'll finish running perfectly. And that's one of the things that you sometimes see in a distributed system, is that all of your services can't come up at exactly the same time. There needs to be some kind of eventual consistency. Now the key one that we care about is the OpenFAS gateway, which is just here. What that allows us to do is install the OpenFAS CLI, and on armhf on Raspberry Pi there's no authentication by default. If you want that, you can turn it on. Just ask on Slack for how to do that. If you install this on the cloud, you'll have to get a password. So what we can do is faas-cli list -- gateway, and then either localhost or the actual IP. And here we see there's basically nothing deployed right now. So OpenFAS has a function store that we can go off to get stuff from, and it uses basically a JSON file. And what I'll do is export store, and now I'm going to go store list and pass in the specific URL for all of the ARM images. So that's what we've got. Let's deploy, we'll deploy node info, and we've got an error because we didn't pass the gateway flag. Now we can actually just set this as an environmental variable as well, and that means it's just a bit less typing. Okay, so we've got node info, and perhaps we could put cert info on there as well. Cert info is one of the ones that I really like because it allows you to check the TLS certificate for a website. So what have we got? Well, that pod for the idler was failing earlier and it worked itself out after 3 restarts. We've now got node info is running and ready, and somewhere we'll get the pod for Figlet. If we pass the dash output wide flag, it will actually tell us what node these things are running on. So we can see cert info is on the node we're on, but actually node info is over here on the other machine. Now there is a tool, k3s, and if we run this, it tells us what pods are running on containerd, literally on the local computer. And I find this quite useful as a debugging tool, and it gives you some sort of output and general data about that. Right, so we've now got the function deployed. Our list command should show both of them, and we can describe one. So we can describe cert info. We've got a synchronous and an asynchronous URL for it. We may want the synchronous one, which means it will execute immediately rather than in the background. So let's see when our certificate will expire for OpenFAS. Not before, not after the 8th month. Okay. How about my blog? Around the same time, so it looks like I might have set that automation up at around the same time. Cool. So the other thing we could do is obviously try the Figlet function. Now there's a whole host of different things that you can do here. You can invoke these through the CLI even, and just pass in some additional data. So Figlet. I wonder if that's correct. Yes, we didn't deploy Figlet. So we're getting a correct error there. Let's also have Figlet. Figlet's great for ASCII art. One of the ones we've done here though is node info. And node info will basically tell you a bit of data about the platform you're running on, and if you run it a few times you will eventually scale it up and you'll start to get different pod names coming back. We can also put in the word verbose here, and then that gives us additional data about like the specific CPUs. We can see the frequency and the branding, and any network addresses that are attached to the container. Great. Let's try the figlet again. Okay, so we've got three functions all running now. We could even try opening the UI. So this is the IP address on my local network, and I can just hit it up on the node port that I've set up earlier. Here's the figlet function, and we can run it in exactly the same way. Okay. The UI here does also expose the same data. You know, we copied the URL in for the CLI. We're working on a fix for that to make it a bit easier, but the UI will only show you what is available. Something here that can be useful is a manifest query. It lets you go and figure out what platform you can run a Docker image on, basically. So one thing that is popular with OpenFAS is this concept of auto-scaling, and I can log into one of my other computers here, and I can start basically a load test. So we do 5 minutes, two concurrent requests, no more than 10 requests per second, and this will now begin. So over on the figlet function, we've got our invocation count currently going up at probably around 10 per second. When we hit a certain threshold, Prometheus will be putting these metrics together. They'll get captured, and then we will trigger a scaling event through Alert Manager. Yeah, so it looks like we can use a get to this, and we can also use a post. So the Hey tool by default is going to be doing a get, but if you have a function that only accepts a post, you can pass in data here too. Right, so now we've got 5 replicas. We can probably run this pod tool, and we see actually 3 of those pods got scheduled on this particular computer. And if we run our watch, you can actually see as much detail as even like the IP address of each pod in the network. So we've got 1, 2 on the first node, 3 on the second, and now we're creating even more, and they're just getting distributed around that network. So we've got 9 replicas right now. One thing we can now do is perhaps even just cancel that. We see we've got 100% of those requests worked. And once the system recognizes that there's no longer that traffic there, these will just scale back. And we see the pods terminating again. What we'll do is we'll go back to the minimum availability, which is 1 replica, and we can still invoke this during that time. It's not like we lose an endpoint or anything like that. All of these are doing safe shutdowns, so it's a graceful shutdown. So there's a quick tour of OpenFAS on Raspberry Pi. We now have a computer that is way faster, that has much more memory, and in the cluster alone we've got something like 8 cores and 8 gigabytes of RAM that we can use. If we look back at our nodes, we'll be able to see that probably there's very little CPU and memory that's actually being used right now in terms of the requests that have been put in. So I hope you enjoyed this. Do check out my Twitter thread for more. There's a whole bunch of different tweets that I've tried to put together to create something interesting. You can even see what that new micro adapter looks like, and we'll see how long that lasts in practice. This is it running on my desktop. So come in, share your photos. Please try OpenFAS. Go ahead, submit a function in the store if you like. There's perhaps one more thing that's worth mentioning though. is when you use k3s, you don't actually get Docker. So if you do want to do a faas-cli new and create your own function, you may want to install Docker, or perhaps do it on a different computer, push that image into the Docker hub and then deploy it or on one of these using the API. Any questions, please feel free to reach out.